My name is Hoan Phan. Again, one more time, I'm working for Marubeni Citizen-Cincom in Fountain Valley, California office. And today I'm going to introduce to you my most favorite machine, and it is the Citizen Miano BNJ 51SY6. So this is the one of the most sturdy and heavy machine. As I mentioned, because all the casting right here, it built up at the box weight all the way around, and its weight 11,687 pounds. On top of that, we have 80 gallons coolant tank capacity. So it adds a lot of weight on the machine as well. So with that, the machine can handle a very big and heavy cut. So another thing, as a machine provider, we understand a lot of machine shop out there concerned about the spaces that the machine gonna take place. So let's look at the size of the machine first. The machine is 103 inches by 60 inches, and it is 67 inches high. So it's very good size of the machine for a lot of place. So let's look at inside right here so you can see what I mean. So inside right here, we have twin spindle and twin turret. And then both of them, it can work independently, separately. So that means literally we have two little machines fit inside of one machine right here. And then this machine was built to run the bar stock OD with the unattended mode. So with that, we need to hook up the machine with a bar loader. So bar loader, we can come up with a different style with the bar loader, which can give you allow you to run 3 feet long bar loader up until 12 feet long. So all the decision is going to be up to you. You're going to make the choices what it fits for you. All right, let's look at inside the machine right here. The main spindle right here, it allows you to run the bar stock in there up until 2 inches in the OD, which is 51 millimeter. And then it's using the S22 collet pad. Same thing like that, but in the sub spindle right here, we're using to pick up the part and transfer and do whatever at the back side right here need to do in order to complete the part. But it is 42 millimeter, which can go up until 1 inch and 5/8. But then we had an option that we can upgrade this one up until like 2 inches as well, and using the same collet pad like the main spindle. Both of the spindle right here has had the capacity to run up into 5,000 RPM. And then whatever the RPM that you command in the program, the machine can get it very quick in just a second. In order to show you, I'm gonna go right here. The control panel has a function right here that we can turn on the spindle in the manual mode right here. So first thing, I'm gonna go to spindle 1 by simply selecting the spindle 1 right here. And then right now, I command the spindle 1 at 3,000 RPM. As soon as I hit start, and then just in 1 second, you can see right here, the spindle RPM reached to whatever we commanded. So it's very quick. And then the same thing in the sub spindle, if I commanded 25,000 right here, 2,500 right here, and then hit start, it also get to the point very quick too, just in second like that. And then we can stop it. Let's look at the machine right here inside. The machine has 7 axes. I can show you right here. So the main turret right here, it can travel in and out with X1 axis, up and down with Y1 axis, and then side by side like this with Z1 axis. The sub turret right here, it is stable turret. It will not move. Can only index to the tool in order to cut. But then the sub spindle right here, it can travel like side by side this way, or you can say forward and backward with the Z2, and then this way with the X2. And then both of the spindle has had capacity with the full C axis that you can command up to 0.001 degree. So that's a very good advantage for you right here that you can use the milling interpolation, which is one feature. It comes standard with the machine. And then also we have another feature is helical interpolation too. It used to be the feature that you had to pay to get it. But then just like a lot of function is now is standard with the machine as well. So with a machine like this, it's running so fast, and when you index the tool and in the rapid mode, everything is become very fast. Just like the main spindle right here, the X2 and Z2, it can travel 20 meter in just a minute. So just imagine that it's really fast. But then this machine has had a lot of features that concern as a safety feature for this machine. First thing we can talk about is this thing right here. It's called the cut-up confirmation device. So what it does, the cut-up right here, when it command in the program, it's going to shoot out, and if it see the material in the front right here, and it say, okay, after the cycle time, maybe the part is not separate from the sub spindle, from the main spindle. So something happened right here, and we'll say, okay, all right, stop the machine right away, and then say, okay, something wrong. And then you can like go check. Maybe you can just replace the cut-up tool. And another thing is we have M code also. The M code is used to check the rotation of the sub spindle, and then also say, okay, if after the cut-up operation, if the tool is breaking or not, it will stop the machine. So we have double side safety check. One is on the top of the program, one at the bottom of the program, is make sure everything go in the correct way. So a lot of things is going to be safety on this machine, and then you can be sure that the limit of unexpected thing can be limited to the least. Another thing that this machine has is called collision buffering. What is collision buffering is when you have the machine travel in rapid mode, and for some reason you have the tool hitting some material like unexpected. Okay, the machine, it will generate it's actually decelerate the feed rate, and then it's also the same time it create another force is going to the opposite direction in order to stop the machine from getting hurt. So this machine is really like safety to run and operate and then running around like that. So the next thing I want to talk is the turret right here. So the turret has had 12 stations, and you can see right here, a station you can equip with single tool like holder or maybe double holder, and sometimes you can have the front turn right here and 2 ID in the back side too. And then we have another holder which is called a quattro holder, which is can use up to 4 tools on one station. That means even the turret is had only 12 stations, but you can have a lot of tools mounting on this machine. And there's another thing that we want to say right here. Each of station right here, we can equip with the live holder. What I mean like that is the turret right here, it built with a tank drive. So each station can be run dependently. It will not follow whenever you input the live holder in here and you turn it on. It's only that the station that you turn on, it will rotate. The whole thing, it will not follow. So that's the tank drive. And then the sub spindle right here is at A station. And the sub turret, the sub turret right here now is at A station. And then 4 station is live. And then 4 station is static. But then the static station, you can have the double plane holder equipped on that. And then all the tool right here for the main spindle and the sub spindle using the 3/4 inch shank. And then for the ID tool, it's going to be 1 inch diameter ID shank. All the live tool on this machine is 25 pneumatic, and then 3 horsepower by itself on the live tool on the turret right here. So it can handle quite a bit like cut with the milling interpolation on this machine with the live tool. So one more thing that we want to talk about is, I mentioned earlier we have a quarter holder. What is the quarter holder is sometimes if you run out of the tool that required for the sub spindle working right here, you can borrow from the main spindle right here. The main spindle can use the tool in the back side right here in order to work in the back spindle. And then sometimes you can do as we call it simultaneously. So simultaneously it can happen either with the static tool or the live tool as well. So with that way we can cut the load of the cycle time, and then we can share the cycle time for the both sides. And since now every like in the back side right here you have a lot of live tooling capability, and then you can share the load as well. So what is the main goal of this machine is we want to cut down the cycle time at least as much as possible. So with the idea that the main spindle and the sub spindle can using both of the turret working independently to have the machine always busy inside, and then you don't have to waste time around to waiting for another another spindle in order to work. Another thing is really good with this machine is it come up with different type of coolant. So we have the flood coolant right here for the main spindle, and the flood coolant for the sub spindle is all separate. You can program it on in handle 1, in head 1 or head 2. It's all separate to control by the M code. Another thing is inside the sub spindle right here we have the flood inside the flood coolant that go through the sub spindle. It helps you to flood all the chips out, so help the sub spindle is always stay clean. Another thing for the high pressure coolant that we can have through the turret right here, and it has 150 psi. It helps you to blow all the chips on the tip of the tool that need to require sometimes you turn some material very sticky, and then it might stick on the tip of the tool. So that way we can make sure that everything go right. So one more thing that I want to mention right here, the machine comes standard with the part catcher right here, and then also the part convey, and then also with right there we call it the chip convey. So everything is standard right here. You buy it and then you get all of it with the machine. You don't have to purchase any option, anything at all. So that is all about overall about the machine. So the next thing I want to go over is all the feature that we have here for the machine. So the machine has a very good feature that's right here. You can see the icon right here. It can access to the page right here, and the page right here, it contains all the good features that the machine has. So first thing I want to talk about is the machining data. So machining data, you can get to it by simply press 2 input, or you can go to app 2 right here. So the machining data is something that unique that we just built for the new machine right now. All machine we're using the work coordinate system, and then it's going to be easier with the MC data right here because we control every information we put in here, and the machine will use all the information right here later on in order to make the movement during the program. So it makes everything way easier by setting everything zero at the main cap right here of the main spindle, or in the sub spindle as well. Everything is going to touch up on the Z axis right here and here. Another thing is we can have a setup, quick change, very good for this machine. So basically you have like lots of a program that run like months ago, and then you want to load it back in and then run it again. So all the information when you fill out right here in MC data, when you prove out the machine, this information, it will go together, it will travel with the program. So for the next time, when you load it in, all the information right here will go back into the machine, and then you don't have to worry about anything at all. It will remember all the things, all the tools that you used last time. So the next feature that we can have, and again, we're going to go back to the custom page right here. We're going to call it is the thermal revision. So the thermal revision right here, it allows you to enter the information whether you're going to use the coolant base or you're going to use the oil base. So we have, throughout the machine, we have a lot of sensor with thermal sensor. So it gives you the ability to control the machine like roll. So when the machine is heat up or cool down, it will not give you a problem. Another thing is right here, we're going to talk about the tool monitoring. Is one of the most features that have a lot of good feedback from the customer too. So tool monitoring right here is allows you to set up the monitor, so to record the load that the tool going to apply. So the first thing we can go over right here, we're going to go select and setting right here. This first page right here, it tells you, okay, what level of the load that you want to stop the machine. And then since you run the machine a lot of time, and then you know, okay, maybe this tool, when the load come up to 120%, which is I set right here, so that when the tool is getting wearing out, and then it start getting dull, so it put a lot of load on the tool, it will record it at the time it reached to 120. It will stop the machine after the cycle right there. So you don't have to worry about getting bad parts and then breaking more tools after that. So another thing right here in this page, with the tool monitoring, it will allow you to record a different axis right here as well. The first axis is going to be X, Z, and Y. And then also with Z axis, with you using live tool, it will let you to record the load on the live tool also. And then spindle 1 or spindle 2, whatever the spindle it involves cutting, it will record the loads at well. And then it gives you the ability to record up until 32 tools. So it's a lot of tool right here for you to record and then keep track on it. One thing right here is I want to mention is the offset right here. So with the offset, we can make adjustment with 5 digits after the decimal point. So it's a really accurate machine, so we want to make the adjustment up until micron. So this is how good the machine is performed. Whenever you put 1 micron adjustment, the machine is actually moved 1 micron, exactly what you command. So it's all the good feature that machine has right here. Next thing I want to go over with the program a little bit right here. Since a lot of people see, okay, this machine has a lot of tool, it's really crowded inside right here. As you can see, we have a lot of tool on the turret, we have double holder, we have everything in here. So it's kind of really crowded machine. So a lot of people get scared because how we can control it, how we're going to program it to make sure like nothing like unexpected happen. So I'm going to tell you, it's very simple on this machine. We have the Cheese 500 code right here. It will tell the machine exactly what tool we're using and where we're going to move it, and then it will catch up any interference if it happened during the program moving. So it's really simple to program it, and then basically head 1 right here, we control the main spindle. And then head 2 right here, we control the sub spindle. So sub spindle right here working with the sub turret, the main spindle working with the main turret. And then sometimes we have the G530 mode, which is the synchronized mode. It allows you to use the main turret to work simultaneously for the both spindle. So with the programming and all the code, all the queuing code, it makes everything way easier than you think. So it makes everything is more sense in the way that you control. Okay, if you call the tool, it's going to react right away exactly what tool in what mode that you want to run. So, like I said, very simple machine, but it's good performance, easy way to program. Heavy machine, handle big cut with a lot of tool ability. We have a lot of holder, variable holder for you to pick up, either one single holder, double holder, triple, whatever you can think of. And then also the same thing too with the live tooling. We can have the live tooling that work for main spindle only, or we can have double live tooling just like this one right here. It can use the live tool to work for the main and the sub as well. So this all information that I gave you for the machine. And next we're going to have a video that we already recorded to show the machine performance. So this is the next video we're going to see.
Let's take a look now at this part that we're running on the BNJ 51SY6. Note the compact size of the machine, FANUC control. Both spindles come into operation and play for simultaneous turning, front and back side. Turning the OD on both spindles. ID work on the front side while we're finished turning on the back side. The live spindles are 6,000 RPM, high torque spindles. Do some heavy duty machining this way. Right now we're just chamfering on the front side. What we're going to do is we're going to come simultaneously working front and back using superimposition. To save time, we're drilling through holes on both sides in different positions. Axis superimposition allows the machine to know where its positions are of each spindle relative to the other. Now doing a boring operation in the front side, back side drilling, utilizing a boring bar here. Thread milling on the back side. As you can see here, C-axis. Front side, we're using a milling interpolation, again using the C-axis. You'll see this right here. Part eject into the parts catcher, standard feature of the machine. Note the unique design of this back turret, allows for clearance, faster tool change times, faster pickoff. Part picks off, spindle sinks. Machine cuts down, ready for pickoff. Cut it off, retracts the part.
All right, welcome back everyone. Now I'm going to introduce to you is Jack McGinnis. He's one of our sales right here in California office.
Thank you, Hoan. Appreciate it. Good job. So just in wrapping up, I did a great job explaining the machine. The Miano machine, Citizen brings this machine in ready to run, ready to go. As Hoan had indicated, the spindle, very rigid. We've got 2 sets of angular contact bearings in the front and a set of roller bearings in the back. So ready to support up to a 12-foot, 2-inch bar. We can handle that. The machine comes standard with collet noses for both the main and the sub. Cut-off detection, so we know the bar has been, the part has been cut off. Parts catcher, parts conveyor, patrol light, and all the control functions that used to be options years ago are in there now standard. This thing is ready to go out of the box. Again, very heavy, rigid construction. We can take aggressive cuts on this machine and very, very accurately. So with that said, if you have something you'd like for us to look at for you, a part, we're here to help. Miano's a very good machine. Out here in the Southern California territory, I've got machines literally that are still running today, go back from 1990, 92, 93. Still running every day, many, many of them. So let us take a look at what you have. We can offer a solution. Thank you. I think now we're going to Glenn. Questions. Questions and answers.
So first question we have, can we do thread rolling operations?
Yes. Yes, we could put a thread roll in the machine. And certainly we could. We've got all the motions required to thread roll on this machine. Thread mill on this machine, thread roll on this machine, anything you require to that effect. Thank you. Appreciate your attendance.
All right, thank you, everyone.